Don't forget to subscribe and ring that bell.
Why, hello there. We are on to part 4 for the Cliff Notes for the Algebra 2 course, or the summary. Easy summary. For Algebra 2 course, if you are taking the Regents exam, let's get going because we are going to start by dividing polynomials. I like it a lot. I used to teach two different ways. I used to teach reverse tabular, and which is what we're going to cover today. And then I used to teach just the old-fashioned long division way. And every year I taught both ways. In a class of 25, one or two kids would always do long division. The rest would do reverse tabular. And it just started to overpower the population. So that's what I only teach now, okay, reverse tabular. First of all, when we're dividing, I hope you know that we need to fill in any missing zeros, okay? Now, what does that mean? Look at my numerator, all right? For my numerator, notice my biggest exponent is 3. That means I should have exponents of 3. I should have an exponent that's 2. I should have an exponent that's a 1, and an exponent that has 0, like for my x's, I should say, okay? Well, I have an exponent of 3. I highlighted that already. I have an exponent of 2. This has 0. Notice I don't have anything that's x to the 1. So I need to fill that in with a 0. So my top I'm going to rewrite as x cubed plus 2x squared plus 0x to the 1 plus 41. And I need to do the same thing to my denominator, but my denominator has an x to the 1, and it should have something with 0 x's, which I do. So there's nothing really missing in the denominator. So how do I set this up? I start by taking my denominator, and that's going to be the right side of this rectangle I'm going to draw. I have an x, and I have a positive 5. Okay? And then I kind of draw this rectangle. All right? And I split those two terms right there. Now, every term in my numerator should be outputted from a corner. The issue is I have one corner here for my x cubed. I have another corner here, and it's always got to be to the bottom left corner, for my 2x squared. I still have 2 more terms. Guess what that means? I need 2 more corners. So I'm just going to draw 2 vertical lines, and I've created my 2 more corners. My 0 x's is going to come out of here, and my positive 41 is going to come out here. I always start in the top left, all right? So the top left, this outputs x cubed. That's my output. It has to be x cubed. What do I multiply x by to get x cubed? X squared. It's one of these multiplication like boxes and such, okay? The numbers on the outside of my rectangle will always multiply. So now I have x squared times 5, that's 5x squared. The numbers on the inside all add together. And the reason we do these out of the bottom left corner is because this should combine with this to output my 2. So if I have 5x squareds, right, and I want 2x squareds, that means I got to have negative 3x squareds that combine. So the insides always add, the outsides multiply. Okay, so let's do something else here. Now I have this 3x squared. I repeat the same thing I did with the x cubed, meaning what do I multiply by x to get my 3x squared? Negative 3. Well, negative 3x times x is negative 3x squared. Now I got this outside that I can multiply by this one. 5 times negative 3x, negative 15x. Okay, now we're to a point, again, where this inside should combine or add with this inside to output 0. Well, I don't know about you, but if I have negative 15x, that means positive 15x I would combine to get my 0. And again, I do the same thing I did when I had my x cubed here. and my negative 3x. I have another top box. What do I multiply by x to give me 15x? A positive 15. Okay, positive 15 times positive 5 is 75. Now, if these numbers match, if my 75 matches the output, because there's only one box, there's nothing I can combine to get the 41. If that was a 41, I'd be done. But if they don't match, okay, if they don't match, if the bottom right doesn't match its output, guess what? There's a remainder. So here's how we get the remainder. I'm running out of colors here. I have 75, but I got to make an adjustment to it to make it so that it equals 41. So if I have 75, what do I add to it to get to my 41? It's just a one-step problem. I just subtract 75 from both sides, and I'll get negative 34. That's not a fraction. I should really write it like this. So I would have to combine a negative 34 to 75 to get back. So I would have to subtract 34 from my 75 to get the 41. This adjustment, that's my remainder. Okay? And how do we write remainders? We always write remainders. Okay, we have a negative 34. We always put them over what we divided in, or the denominator, x plus 5. This is the answer right here. X squared minus 3x plus 15 minus 34 over x plus 5. And there you go. Now, I like synthetic division, but my one caveat, the one suggestion I give to my students is you should have 1x in your denominator. You see how it's 1x plus a number, plus 5? So when it's like that, I tell them go ahead and do synthetic. If it's not, I always recommend doing the reverse tabular. All right? So what is this synthetic? What I need to do for synthetic is I need to take my x plus 5, and I need to solve for it, right? Like I'm T-boning a factor. X would end up being negative 5. Like if this was a factor and I had to solve, x would be negative 5. It's this negative 5 that I'm going to use in my synthetic division. I put it in this sort of like half a box thing. I still need to fill missing zeros. That doesn't change. Please note, this is the same problem we just did, so we should come up with the same answer. All right? And notice we're missing x to the 1. So I technically have x cubed plus 2x squared in my numerator plus 0x to the 1s plus 41. All right? Now, what I do with synthetic is I only write the coefficients. I don't care about the x's. This is a 1 in front. So I write a 1, a positive 2, a 0, and a 41. Okay, and I draw this line down here with a little bit of space. I always just drop the first term. After that, whatever this bottom term is, I always multiply by the number in the box. 1 times negative 5 is negative 5. That's my next number above the line. Whatever that is will always get added to the top number. 5, negative, and 2 is negative 3. Okay. Again, I multiply this number times my number in the box. Negative 3 and negative 5 is a positive 15. That product always gets added. 0 and 15 is 15. Okay, 15 times my negative 5 is negative 75. And again, I just combine these. 41 plus a negative 75 is negative 34. This last number is always my remainder. But how do I write the quotient, the answer that's in the polynomial that we're looking for? I start with my number in the here. This is the one that gets 0 x's. This gets x to the 1. This gets x squared. And if there were more numbers, it would just keep on going. Okay? So I have 1x squared minus 3x's plus 15 without any x's. And oh, my remainder is negative 34, and that always goes over the denominator. x plus 5. That was a lot easier, I think. It's a lot less work. It's not that it's easier. It's a lot less work than this. But notice it's the same exact answer that we got. Okay? Again, I would make sure you have one x plus or minus a number to do that. You got to solve for it first. That's the number that goes in the box. Then just take the numbers. All the letters go bye-bye. Okay? Now, this is a cool little cheat code. And it's as follows. The remainder theorem. Okay? So, we're going to solve for the denominator, what's being divided in. And then whatever that is, when we solve it, that gets plugged into the numerator, or that gets plugged into the bigger equation. And whatever the result is the remainder. Now, please keep in mind, if they're asking you to divide things, this does not give you the quotient or the answer to a division problem. It only gives you the remainder. I really should have used the previous problem because we know the remainder should have been negative 34. But here's the thing. If the remainder is 0, then you have a factor. If you have a number, okay, 5, that goes into a bigger number, evenly, it goes in 4, and there's a remainder of 0. If the remainder is 0, this is a factor. 5 is a factor of 20. So if they ask you, is x plus 3 a factor of this? You really, some people still like to divide it in. Okay, divided by x plus 3. Some people still like to divide it in, and you can do that. Like a lot of people that are like, Visca, I'm trying to remember too much. I'm just going to do synthetic. I'm going to do this, and I'm just going to look to see what my remainder is. Okay? But you don't have to. The process tells me I take my x plus 3. I set it equal to 0 and solve. X would have to equal negative 3. This number is now going to get plugged into these x's in just the numerator. And whatever value that gives me, I don't know why I didn't include the 4 there. Okay? That's my remainder. So if I take x to the 4th minus 10x squared plus 9, and I throw x equals negative 3, if I throw a negative 3 in for these x's, that's squared. Okay? Whatever that number is my remainder. Okay? So I know what the answer to this is. I could do this quickly, but we'll still do this in the calculator. Why not? It's hash LCD, which will be right there. Bam. Ba-da-da-da-da-doo. I'm going to second quit. Clear this poopy out. And we got negative 3 to the power of 4 minus 10 times negative 3 squared plus 9. Boom. That's 0. That means if I divided, okay, if I divided this out, my remainder will be 0. So this equals 0. So let's answer this question. Is x plus 3 a factor of x to the 4th minus 10x squared plus 9? Explain why or why not. Yes. Let's answer the question. X plus 3 is a factor since the remainder is 0. Then I always say by the remainder theorem, because that's what I used. Okay? Now look it. Do not fall into the habit of saying, since there is no remainder. This, you will get points taken off. You can't say there's no remainder. You have to say that the remainder is 0. There is a remainder. It's 0. Okay? Now, if this number wouldn't have been 0, if it would have been 20, I would just say no, x plus 3 is not a factor since the remainder is not 0, or the remainder is 20. Okay? Now, I mean, I don't think I got to prove to you that the remainder is 0 by actually doing out the work. If I would have taken this problem here, and I would have taken, I solve for x plus 5, I get x equals negative 5. If I threw a negative 5 into every x in the numerator, okay, if I take this and I throw a negative 5 in for this x, and a negative 5 in for this x in the calculator and hit enter, I would get negative 34. It would not give me this part. It would just tell me the remainder, negative 34. Okay, so if you have to divide, you got to use synthetic or reverse tabular. But if they're just asking you if something is a remainder, plug it in. Radicals. Two ways to do these. Okay, I like to use the way where I know my multiplication facts and it's less work. Or you can use a way where, you just keep on breaking things down like a prime factor tree with all the leaves. You can do it that way as well. I'll show you both ways for this first one. Okay, so first of all, this is a square root. Okay, if it's not written by default, it's 2. So I got to figure out what the square root of 32 is and what the square root of x to the 9th is. I'm going to handle these separately. Okay, square root of 32. Because I know my factors, I know 32 is 16 times 2. If my 32 is under the square root, my 16 and 2 need to be under the square root. Why did I pick 16? Because I know that 16 is the biggest perfect square that goes into 32. And the square root of 16 handles itself. That's just 4. And then the square root of 2 I can't simplify anymore. Okay? X to the 9th. Remember, this is a square root. This just turns into a division problem. Look what I have here. It looks like I have 2, 9 divided by 2. 2 goes into 9 4 times, the remainder of 1. This right here is going to tell you how to simplify what I originally started with. Okay, 4 x's come out of the radical, and 1x remains in the radical. Okay, this is what comes out of the radical, and the remainder is what remains. You see the 4 and the 1? They're right there. I think that's easier than trying to find out the square root of a number, simplifying it. So now we're just to the point where we just combine everything that's outside of the radical, my 4 and x to the 4th, go together outside of the radical, and everything inside 2 x to the 1 stays inside. So that's how you do it if you're good with finding perfect squares and multiplying and knowing factors. So what's the other way? Okay. I'm going to do it off to the right, and then I'm going to erase it. Screw that. I'll do it below here. Square root of 32x to the 9th. I'm still going to kind of handle these separately. Okay. Notice this is a square root, so groups of 2. 32 is, I don't know, let's call it 8 times 4, isn't it? Still under a square root. 4 is 2 times 2, and 8 is actually 2 times 2 times 2. So if I multiply 2 times 2 times 2 times 2 times 2, okay, I would get 32. These are still all under a square root. We've done nothing except change that 32 into all these prime numbers multiplied together. I can pull out groups of 2. Okay, how many groups of 2 do I have? I have one group of 2. I have a second group of 2. That means 2 to the power of 2 would come out. And this 2 that's by itself would stay in the radical. I hope you know that 2 squared is 4. Okay, and I do the same thing with the x's. I have 9 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? How many groups of 2 do I have? Because remember, this is a square root. 1 group of 2, 2, 3, 4 groups of 2. So that's what all comes out, the 4. 1 stays in. So again, I rewrite it. 4 x to the 4th is on the outside, and my 2x is on the inside. Okay, so there you go. That's how you do that with the little piggies thing. The little piggies that go outside the house. They get in little groups of 2. Now, what happens if it's not square root, it's a cubed root? Well, If you're good, I'm going to handle these separately. I'm going to handle the 32, the x to the 7th, and the y to the 5th separately. So the cubed root of 32, I know 8 is a perfect cube, and I know this has to be 8 times 4. These are also under cube roots. The cubed root of 8 is 2. I cannot simplify the cubed root of 4. There you go. It's done. Don't got to put groups together. I don't have to do anything. I'm solid. I'm good there. All right. My x to the 7th. The same rules apply as before. This is the cubed root of x to the 7th. So it looks like I'm just dividing. 3 goes into 7, right? So how many times does 3 go into 7? 3 goes into 7 twice with a remainder of 1. Again, this tells me how many come out? X squared. How many remain in the radical? There's my 2 and 1, and that's a cubed root. And I do the same thing with the y. Okay, I got y. It's the cubed root of y to the 5th. I'm going to divide 3 into 5. 3 goes into 5 once with a remainder of 2. 1y comes out. 2 y's remain. The radical remain, the remainder remains in the radical. And again, we just get to a point where we write everything outside of the radical together. 2x squared y, 2x squared y, times the cubed root, 4x y squared. Now, you could do the same little piggy factorization, prime factorization with this, but instead of taking groups of 2, you would have to take groups of 3 out. Okay? Simplifying radicals are nice, but what if we have to solve? Well, in order to solve a radical, the first thing you got to realize is you need to get the radical alone on one side before you undo it. So everything that's under the radical is 2x minus 3, and this radical need to be alone. That means I've got to subtract 3 from both sides. So I've got the square root of 2x minus 3 equals 5. Now, okay, now to undo a square root, I square it. What do I do to one side? I do to the other. This goes bye-bye, and I have 2x minus 3 equals 5 squared is 25. 2 steps and we're done. I hate to break it to you, kids. 2 steps and we're done. Let's add 3 to both sides. 2x equals 28. And the last step here is we divide by 2. And my x equals 14. All right? Now, the strange thing with radicals, sometimes when you get to this step, you end up with a quadratic and you get 2 answers. But you should always check, because sometimes we get what's called an extraneous solution. That means we do the work and we get an answer that algebraically comes out, but when we try it, it just doesn't work. What do I mean? I'm going to take what I started with right here. 3 plus the square root of 2x minus 3 equals 8. All right? And they're not telling me to check this. So what I'm going to do is I'm going to put this in the calculator, and I'm going to make my x 14. And I'm going to see if it equals 8. All right? So here we go. Bang. Oh, little delay here, kids. Right there. Oh, dang you. Clear this out. So we have, okay, the left side of that equation, it's 3 plus the square root of 2 times my x, which is 14, minus 3. Does that equal 8? And it does, and it works. It works to a T. So, I mean, 8 equals 8, and it checks.
Don't forget to subscribe and ring that bell.